In today's Python tutorial, we'll be diving into operators in Python, one of the most essential concepts every developer must know. Whether you are coding logic, comparing values, or performing math, operators are everywhere in Python. We'll explore them step by step with real examples. So, operators are special symbols or keywords used to perform operations on variables and values. So, Python supports major 7 types of operators: arithmetic, comparison, assignment, logical, identity, membership, and bitwise. So we'll go to arithmetic operators. It is used to perform mathematical operations. So you can see there are several operators in mathematical or arithmetic. You can see addition, subtraction, multiplication, division, floor division, modulus, and exponential. So we will create two variables, a equals to 10 and b equals to 3. Now we will do all these operators. So print addition, a plus b, print subtraction, a minus b, print multiplication, a star b, print division, a divided by b, print floor division. See, floor division is nothing but if you divide two numbers, that means 10 divided by 3, you will be getting 3 point something. So they will, if you do the floor division, it will take off the decimal places and it will take the only the integer part from it. It won't consider the decimal place. So if you do the division, it will show the division. It will show the decimal places also with the integer. But if you are doing the floor division, it will show only the integer. If it is 3.2 or 3.5, it will show only 3. So a floor division. Now the next one is modulus. Modulus is actually the remainder. When you divide two numbers, you will get a remainder. That remainder is the modulus. Print modulus, a percentage of b. And then finally exponentiation. Exponentiation is actually the square of a number. That means it is 2 exponentiation of 2 means 2 raised to 2. So a raised to b, that means 10 raised to 3, 10 into 10 into 10. So we will see the results of it. You can see addition, it is 10 plus 3 is 13, subtraction is 7, multiplication is 30, division you can see it is 3.33, and floor division, they will take off this decimal part and it will show only the integer part, that is 3, and the modulus, that is the remainder, that is 1. Exponentiation is 10 raised to 3, 10 into 10 into 10. The next operator is the comparison operator, that is also called relational operator. It is used to compare two values and it will return true or false. So it will compare a and b, that means 10 and 3, and if it is equals to, it will return true or it will return false. 10 equals to 3 means that is not equal, so it will return false. So there are some operators regarding that, that is equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. So you can assign some values, x equals to 7, y equals to 5, and you can print equal to x equals to y. That means you have to give double equals. Then print not equal to x not equal to y. Print greater than or equal to. We'll skip this greater than and less than because you can do the same thing in greater than or equal to. So x greater than or equal to y. Print less than or equal to x less than or equal to y. You can see the result. So x is 7 and y is 5. So equal to is false, not equal to is true. That means x is not equal to 7. Y greater than or equal to is 2, true, because x is greater than or equal to. That means anything is possible. It can be greater than or it can be equal. Now it is greater than, so it is true. Less than or equal to is obviously false because x is greater than y. So definitely it will come to false. So the next one is assignment operators. It is used to assign values to variables. Mostly we will be using it in loop statements to increment the loop values, especially if you are giving I. So instead of giving I is equal to I plus 1, we will be giving I plus equals to 1. The same thing, we have certain operators for that, equals to, plus or equals to, minus or equals to. If you want to multiply, divide, take the floor or take the modulus or take the exponentiation, you can, instead of writing a big statement, you can write it in a small way. So you can take a simple example. You can write an example: a equals to 10. Print a is a. Now you can give a plus equals to 5. That means the value of a got incremented 5. A became 15. So you can write it as print the value of a is a. We can do multiplication also. A star equals to 5. So that 15 you are multiplying into 5. So print the value of a is a. Can execute it and see. First the value of a is 10. Now then we incremented it by 5. It got 15. Then we multiplied it by 5. And that 15 got multiplied it by 5 and it got 75. Now the next one is logical operators. It is used to combine conditional statements. So it is mainly used for checking an if condition. So if x is greater than 2 and also if x is less than 6, you can use this AND operator instead of writing two if statements. You can write it as if x greater than 2 and x less than 6. The same thing you can do for OR also. If either one is true, you can use OR. Or if you want to check in a negative way, you can use NOT. We can see an example of it. We will use x equal to 4 and print x greater than 2 and x less than 6. So it will return true or false here. So actually it will return true because it is greater than 2 as well as it is less than 6. So print x not x greater than 2. So not x greater than 2 means actually it is x less than 6, less than 2. So that will come to false. You can see one is true and one is false. You can use this in an if statement. So next one is identity operators. It is used to compare memory locations. We can use this in list data type. So one is and one is not. So is means if both are the same objects, is not means if it is in a different object. So you can write a list function here, a equals 1 comma 2, and b we will write an integer 2, and we will give c as a. That means c is also now 1 and 2, the list of 1 and 2. So print a is b, print a is c, print b is c. You can see first actually a is not b because a is a list and b is data type. I mean b is integer data type, so it is false. Now second one is a is c. Actually that is true because a and c are equal, same. And the third one is b is c. B is not c because b is an integer and a is a list. So they will have different memory locations. So the next one is membership operators. It is used to check for membership in a sequence. So there are two other. One is in and one is not in. So if you are giving a sequence of values and you can check whether any variable is there in the sequence or any variable is not there in the sequence. You can use it in a list data type. You can see as num equals 1, 2, 3, 4, 5, and you can check whether 3 is there in this list. So print 3 in nums. So definitely it is going to return true because 3 is there in nums. So print, actually 4 is there in nums, but we will check whether it is not in nums. 4 not in nums. You can see another one also. Print 7 not in nums. It is not nums. Oh yeah, it is nums. So you can execute it. First one is 3 is there in nums, so it is returned as true. Second one, 4 is not in nums. Actually 4 is in nums, so it has returned false. The next one is 7 not in nums. Of course 7 is not there in this list, so it has returned true. So the next one is bitwise operators. It is to operate on binary numbers. So you can see there are different operators: and, or, not, left shift, right shift. We will see an example. Suppose a equals to 5. Actually, the binary value of a 5 is 101. Now, how you will calculate 101 is, it should be all the numbers you need to divide by 2. So it will be 5 divided by 2, and you will get the quotient as 2 and remainder as 1. So you will take this remainder And this quotient, once again, you will divide it by 2. So you will divide it by 2 by 2, and the same quotient will come as 1, and remainder will be 0. But still 1 is there, isn't it? So this 1 you need to divide by 2. So 1 divided by 2, and the quotient will come as 0, and the remainder will come as 1. So you need to take all these reminders, 1, 0, 1. So that means binary 101. The same way you are taking b equals to 3, and the binary for b is 011. You can calculate it through this way itself. So we can use this bitwise operators for these two binary numbers. So print a and operator b, and print a XOR operator we will use b. So you will get the result like this. The difference, if you do the binary operations a and b, you will get 1. If you do the XOR of a and b, you will get 6. So now the next one is operator precedence. It is like how the operators are going to perform, like which operator is going to come first and which operator is going to come second. So the first one, definitely they are going to take the ones that we write inside the bracket. So we are writing 2 plus 3 inside this bracket, and outside the bracket, if you are taking into 6, that means first it will do the operation 2 plus 3, and that you will get 5, and that 5 will be multiplied to 6. So first one is whatever you are writing inside the brackets. Next one is exponentiation, that is square of the number. Then it will go on like this, and the last one is equals to, plus equals to, and minus equals to. This is the way each will operate. So it determines the order in which operators are evaluated in an expression. Suppose you are writing print 10 plus 5 into 2. You might be thinking that, okay, it will first calculate 10 plus 5, that is 15, and then 15 into 2, that means 30. So according to this, you can understand first it will take multiplication, then it will take addition. So actually what it happens is first it will take 5 into 2, then it will take plus 10. That means 5 into 2 is 10, and 10 plus 10 is 20. So instead of doing it one by one, it will check according to the precedence. You can get the value 20. So there is another rule also, it is called associativity rule. So when two operators of the same precedence appear, associativity determines the order. That means, okay, you are giving, instead of giving 10 plus 5 into 2, you are giving 10 divided by 5 into 2. So actually this into multiplication and division comes in the same category. That means in the same precedence. So what will happen then? Which it is going to take? So left to right associativity, most operators, example, plus, addition, subtraction, division, and multiplication. So it will take from left to right. So whatever your operator you are going to give in the left side, it will do the operation, then it will move to the right side. So that means print 10 divided by 2 into 5. So this division and multiplication comes under the same precedence. So what will happen is it will do the first one 10 divided by 2, then it will do the result multiplied by 5. So 10 divided by 2 is 5, 5 into 5 is 25. So it has written 25. So the second rule is right to left associativity, that is for assignment operators, assignment as well as exponentiation. So you can see the assignment operators, they are almost similar, having the similar precedence. So in this print statement itself, if you want to do it in a different way, if you actually want to go for, first, if you want to go for 2 into 5, then instead of writing it in a different way, you can write it in using parentheses. That means you can see here, isn't it? The highest precedence is parentheses. So you can write it here like this, print 10 divided by, inside a bracket, you can write 2 into 5. Now here what happens is, first, instead of doing 10 divided by 2, it is going to do 2 into 5. That means 10. And then it is going to divide it by 10. And you will get the result as 1. You can see the result came to 1. So that is one good thing which we can implement it in our operations using this precedence concept. Hope this was a valuable one. Have a nice day.